All right, so as I promised you guys, I'm going to do each of the free response questions in the packet one by one and upload the videos to YouTube so that you can watch them instead of just looking at the answer key. Hopefully it helps and it answers the questions ahead of time. But again, if you still have questions, by all means, either email me, comment, or ask in the live Google Meet, which are now Mondays and Wednesdays. Okay, so go ahead and check the stream for that. All right, so for this first one, it's a calculator active question, and it gives you the velocity of the particle. Right here, here's the velocity function. And it also gives you another important piece of information, so don't overlook it. It tells you the position at 2 is equal to 2 at t equals 4. All right, but make sure you understand that this is, in the yellow, is the velocity function, and the point they're giving you is a position point. All right, so part A, at t equals 4, is the particle speeding up or slowing down? So for part A, we need to know, is it speeding up or slowing down? To determine if a particle is speeding up or slowing down, you need to both look at both the sign of velocity together with the sign of acceleration. If the signs are the same, it'll be speeding up. If signs are different, it'll be slowing down. So we need to figure out what is the velocity at 4 and what is the acceleration at 4. It's a calculator question, so let's go ahead and go in the calculator. I'm going to store or define v of t as the function. So v of t is 1 plus 2. Make sure you're in radian mode, which I am. Sine control division t squared over 2. Now I'm just going to go over here and add the times. Again, I think if it's a number, it doesn't matter, but if it is a constant variable or anything in terms of x or t, please make sure you don't forget that multiplication symbol. All right, so I'm going to hit enter, and there's v of t. So now I want to evaluate v at 4. So v at 4 is 2.9787, and I also need the acceleration. So the acceleration is the derivative of velocity. So let's just go ahead and use our derivative function here from the menu. We're doing it with respect to t because our function is stored as v of t. And you don't need the actual function for acceleration. You want to know what is it at t equals 4. So we're just going to type it into the calculator like that. All right, so now control enter, it gives us that value right there. So it's clear that we have a positive velocity but a negative acceleration, but we need to make sure we document that on our paper. So v of 4 was 2.9787, and the acceleration at 4 was negative 1.164. So now this was greater than 0, and this was less than 0. Okay, so since v at 4 and a at 4 have opposite signs, the particle is slowing down. All right, now let's go to part B. Find all times t over this interval when the particle changes direction. So a particle changes direction where velocity changes sign. So we need to look at a graph of this. Okay, and let's go into the graph. And now remember, when you graph, you need to graph in terms of x. Just like we're back in the classroom, right? So instead of v of t, make sure you type in v of x. Now, there's a lot going on this function over its entire domain, but we really are only looking from 0 to 3, so make sure you change your window and are only focusing on that domain, because the function can be doing so many other things throughout the entirety of its domain. You want to make sure that you're only answering the question for what interval they're asking you to discuss it upon. All right, so it looks like there's one spot where it changes direction because there's one spot where the velocity changes from positive to negative, aka from above to below. So I'm going to analyze and find that spot. All right, I'm actually just going to change my settings to make sure I give a little more than 3 decimal places. There we go. So at t equals 2.7075, this particle changes direction. So let's go back and document that. All right, so at t equals 2.7075, v of t changes signs, therefore the particle changes direction. All right, and you don't have to show the graph. You just need to discuss what exactly you looked for on the graph to answer that question. Okay, and again, it didn't say how many times. It says find all times t, so make sure you answer that question exactly the way they asked it. All right, part C, find the position at t equals 0. So let's remember here that they gave us the position at t equals 4. So we know the position at 4 was equal to 2. So we know that. They gave us that. We need the position at 0. Now, what else do we have? We have the velocity function. So how do we get position from velocity? We need to integrate. So this is the fundamental theorem of calculus. You don't need to tell them that. I'm telling you that for the sake of knowing what theorem you're using. So if I integrate from 0 to 4, the velocity, I get back the position at 4 minus the position at 0. Now we have the calculator, so we can go ahead and actually get an evaluated value for that. I'm going to scroll this up. So in the calculator, I'm going to go back home and integrate from 0 to 4, the velocity function. So there it is, 5.8150. So 5.8150 is equal to, this is a position that we know. We know the position at 4 was 2 minus we don't know the position at 0. All right, so to get x sub 0 on its own, I'm going to subtract 2 and then divide everything by negative, which means x sub 0 is going to be equal to negative 3.815. And that's our answer for part C. It's a little bit weird. I'm going to go to the left now. I should have done C on the left, but that's all right. Doesn't matter where it is as long as it's done, right? Next part says find the total distance. By definition, total distance is equal to the integral of the absolute value of velocity. Okay, it's absolute value because total distance takes the positive of any negative movement. So just because you're moving to the left doesn't mean that you're not accumulating distance. So you need to take the absolute value. Now this is a calculator question, so you needed to state this, and then all you need to do is plug that in your calculator. So your total distance is going to be from 0 to 3. Now again, I'm going from 0 to 3 because it said from t equals 0 to t equals 3. And then the LOL, which stands for the absolute value, but looks like LOL. And then V of t. So we get 5.301. 5.301. Okay, again, it said from t equals 0 to t equals 3, so make sure those are the limits of integration that you use. And that's it. That's number 1. Took me 10 minutes. In the past, you got 15 minutes, so obviously we are under the amount of time, which would give us 5 minutes for the other problem. Unfortunately, I'm not sure what this year's exam will be like, but at least we know that it would have taken us 10 minutes. All right, I will do the next one in a different video.